Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is IQBAL bin Ibrahim and my matrix number is 208198. So today I will present to all of you about the lab test of Ecc3115. So let's go. Alright, so when we see the circuit, we need to analyze the circuit and understand on what type of circuit is this. So as we know that we can see that this is an RLC circuit, but which type is this? So in RLC circuit, there are step response and the natural response RLC circuit, but this is a step response of RLC circuit. So how do you know that this circuit is the RLC step or RLC step response or the RLC natural response? So the difference is the natural response, which means that we disconnect the inductor of the capacitor from an active source by opening the switch here. But the step response of the RLC circuits means that we connect the inductor and the capacitor to an active source by closing a switch. So that's the difference. So as the explanation going, we can see that this is the step response of RLC circuit. So and then after we know that what type of circuit is this, we need to analyze all the components so we can easily rebuild the circuit in the multi-sim software. So here we have the 24 milliampere of DC current, a switch of SPDT switch, capacitor of 25 nanofarad, 25 millihenry of inductor, and also a variable of resistor. So here we see that we need to complete three types of circuits, which is 625 ohm, 500 ohm, and 400 ohm of resistor. So we need to complete three circuits with the same amount of other component but different amount of resistor. Three different amount of resistor. So without further ado, let's jump into the multi-sim software. Okay, now when we have analyzed the circuit, we can easily find and rebuild the circuit in the multi-sim software. So here, 24 milliampere, we have SPDT switch, we have the capacitor, inductor, and also the first resistor that we need to find, 625 resistor. So let's set up this oscilloscope into scale of 100 nanosecond with a channel A scale of 10 volt. Alright, so let's play. Alright, yep, this is the one. So as we see, the waveform, or I call the waveform, the graph of this 625 ampere, ohm of resistor, we can get this type of waveform. So if we do the calculation, you can see that 625 ohm of resistor bring an underdamped graph. So this is the type of underdamped graph. So the calculation will be explained later. I have do the calculation here that underdamped, when we calculate the alpha is less than the omega naught, and here we can see and determine that this is an underdamped circuit. So next we will jump to the second one. So as I mentioned before, the amount of another component is the same, but the one that changed is the resistor only. So the second one is the 500 ohm. So let's see the graph. Play. Oops. Alright, so let's see the graph here. So this type of graph is the critically damped. So how do we know that? I've done the calculation here that it says that 500 ohm bring a critically damped circuit because the amount of alpha is equal to amount of omega naught. So let's jump to the third one, and the third one is 400 ohm. Alright, so let's play. Okay. So alright, so this is a graph or the waveform for the 400 ohm resistor. You can see this is an overdamped waveform, So because of, as I have calculated here, the alpha is more than the omega naught. Alright, so let's compare both of these three. Okay, so this is for the 625 resistor, this is for the 500 resistor, and this is for the 400 resistor. So first thing first, let's play. And alright, let's pause this one. So let's see, let's compare. Yep, as you can see here, all three graphs are almost the same but different in So this is the overdamped circuit graph, this is the critically damped graph, and this is for the overdamped graph. So that is for the simulation. So as mentioned before, 625 ohm brings an alpha less than omega naught, which means that this is an underdamped graph, and R is equal to 500 can make alpha is equal to omega naught, which means critically damped circuit, while number 3 R is equal to 400 ohm brings alpha more than omega naught, which means that this is an overdamped circuit. So if we put all the values, the calculation here, just input the formula and the values, and the time is in the nanosecond, we can get this answer. While this simulation, we can get all the values from this from the oscilloscope values. We can search from this time and the channel A output. Alright, so after we done searching for the values, we can straightforward make the graph. So I show you the graph. The graph is almost the same from the calculation and the simulation graph. So I think as a conclusion, the graph is verified, and we can say that when the graph is under dam, it will go over current, and if the graph is critically damped, it will go normal and the same as the overdamp. So I think for the most suitable resistor or circuit that can be used is the critically damped, as the circuit does not undergo over ampere or less ampere. So that's all for me. Thank you.